everyone who's in the audience, thank you for coming. Hope you've had a good time so far. We have a really nice discussion session now where we're going to talk about large format 3D printing for construction, something I think is talked about a lot, but perhaps we don't all have the greatest understanding of in general. So I've said I've got a few questions for our panel members to kind of keep the conversation going. If you have questions, do pop them in the Q&A on the right-hand side of your screen, and I'll take them when we come to them. The other thing you can do is you can upvote questions. If someone asks a question that you really think is really important to get answered, you can kind of vote that up as well. So we've got about 45 minutes, not 45 seconds. 45 minutes for the panel. We've just lost Dina briefly. Hopefully she's going to be back any minute now. I will keep talking and filling time while we wait for that. So yeah, if you have questions, pop them in the Q&A and we'll answer them as we go. Hopefully Dina will be able to get back in. What I might suggest is perhaps if the two of you would like to introduce yourselves briefly to the audience, just who you are, what you do, and what your role is, something like that.
Sure.
Yeah,
Victoria,
please.
would you like to go first?
No, please go.
Of course. So I'm Hanifa. I work at Photocentric Ltd in the UK as product manager. So in Photocentric, we make LCD-based 3D printers, which we call it MSLA in the industry, or as I said, LCD-based 3D printing is VAT polymerization, photopolymerization. I've been here for 7 years. Before that, I was at Loughborough University working on FDM technology or FFF for interlayer bonding and adhesion improvement. I've been in AM for 10, 11 years. My background is materials engineering in ceramics and also nanomaterials. I've got my master's in University of Sheffield, which is Candice's university. And so my expertise at the moment is larger scale, making larger scale 3D printers in our technology, which is MSLA. That's my focus. I work on materials as well as the printer, as well as the software, and also educational products, which connects these three together. So yeah, that's me. Nice meeting you all.
Perfect. And obviously, thank you for coming. Victoria, do you want to... I've said that just as you've taken a sip of water, sorry. Would you like to introduce yourself?
Of course. So good morning, everyone. Not sure for those of you who haven't seen my presentation earlier, and if you have already seen me, then apologize for repeating myself. Vittoria Laghi. I'm a junior assistant professor at University of Bologna, Italy, but also a lecturer at Massachusetts Institute of Technology. My background is in structural design, so I come from the structural engineering, civil engineering background, and my research has been focused over the past 6 or 7 years on in construction, and in particular wire and arc additive manufacturing. But recently I've also explored different possibilities and applications of 3D printing for construction, so moving along the concrete 3D printing, along with a joint collaboration with the TU Braunschweig in Germany, and everything that concerns large scale, really.
Wonderful. So it looks like Dina might be having some trouble with connection. I think in the interest of time, we'll go ahead with start with the panel, and hopefully she can come back and join us and join in with questions as we go. So I guess, oh, hey, Dina, welcome back.
Yeah, sorry for the...
No, that's fine. We know it happens. Do you want to very quickly introduce yourself if you can?
I'm assistant professor at the British University Egypt with an architecture engineering background. I've been getting my bachelor, my master's, and my PhD from Cairo University. And lately I have been specialized in 3D printing, attending last year a very intensive program at IAC in Barcelona, where we did like a very huge one-to-one scale prototype with which we will talk about lately. So yeah.
Wonderful. I'm very excited to have three of you who obviously have such great expertise in the area and actually such different expertise. I think that's really nice for a panel session. I guess just for those of us who don't really have much to do with the construction area, when we talk about 3D printing for construction, what sort of applications are we talking about? And I guess quite often we see the big scale, oh, could you 3D print a house, that kind of thing. But what, is that all there is to it? Are there other things that we're considering in that? Dina, I'll come to you first on that. And then if the others want to jump in, then you.
I think lately in the last 10 years, 3D printing in construction started to get more famous, where we see a lot of applications, especially in housing. And why housing? That because as we are facing a lot of increase, so we need to find a very fast technology that can afford us a lot of houses in a very short time. But there is a lot of applications that we can see, and for example, that we can print like facades, small blocks, and even the many researchers started to print with using different materials, masonry, steel, carbon fibers, and so on. So it's not limited to the housing, but as we can see that most of the people are targeting to have like much more in this area to explore more with more even friendly material.
Wonderful. Hannaford, Victoria, do you have anything to add on that?
I just wanted to add from, for example, our angle, our technology angle in general, SLA, and larger scale printing. I think one thing that I find it useful, especially for the students, is the printing models, building models, or architecture models to check the design or discuss it. And also the other thing that in high level we find it useful is the testing of the design, like in wind tunnels, when they are printing the whole area, a mock of the whole area, and just test everything around it. So that I find model making for 3D printing very useful. And as Dina said, other parts of the house, it can be a door, it can be a window frame, it can be other elements in the house or in the building, in this construction, that you might find useful, and just 3D print them rather than just make them with conventional techniques.
So an interesting point there, that it's not just the kind of big stuff, but actually kind of it might be smaller sections of something, or it might be something non-house related. I'll come to you, Victoria, because I know I have prior insight that I've seen some mention of other things from you during this morning's talk as well.
Yeah, so to me, 3D printing in construction has for sure huge potential. So it's not just a large scale. So as also Hanife was saying, you can also print like different parts and portions of furniture or other pieces, like non-structural pieces. But when it comes to structural pieces, given that like I'm a structural engineer, so I have like that as my focus, I would say that it's not really the focus should not be on try to replicate and reproduce the entire building, the entire system as conventionally designed, but to try to just like do a step forward and try to efficiently apply this new application, not just to like this new technology, not just to reproduce the same designs that we see, or but it's more, I think, try to be smart and to efficiently use maybe for smaller parts, but not necessarily on the scale. I would really just think about how to overcome some issues, some current issues for construction that could be easily overcome by, let's say, designing in a different way and exploit, the freedom in geometry that 3D printing allows us to do, and overcome those issues rather than like just trying to go big.
And so that's quite an interesting point, because we talk quite a lot in 3D printing about the kind of the general benefits of 3D printing. Do you find they're the same, or do you find they're similar when we go up to larger scale construction, or do you think are there different benefits and limitations that we start to see at that scale? I'll stick with you, Victoria, and then the others can perhaps jump in.
Yeah, so I think it's actually a very good point. So there are, I think, pros and cons in like increasing the scale of the system. So when you're talking large scale 3D printing, I think there are some issues that could be easily, I wouldn't say just not considered, but that do not play like such a crucial role. Like, for example, maybe the scale of the irregularity, or the precision, the accuracy in the 3D printing. For example, when it goes like large scale, you really increase also the scale of that, so it can go up to a millimeter of tolerance, if even more, which is something impossible to think about if you're like taking small parts for, let's say, automotive or other sectors. On the other hand, I think you're also increasing some of the issues. So for example, when it goes to the interlayer, like the adhesion, Hanife, I know, like knows much better than me, but this like becomes even more crucial, because of course you're scaling up also like the layer itself, you're scaling up all these different issues that you need to consider. So I personally think that you should not just take what has been done at the small scale and just scale it up, either like the solution issues. So I think we need to reconsider everything, not really from the beginning, but for sure try to reconsider some of these issues, because to me, when it goes like to large scale, there are again like it's a different perspective.
And it's very interesting to me. I work mostly with powdered polymer processes, so polymer laser sintering, and you talk about millimeter scale tolerances, and I kind of just shrink back into my chair. Like that's, yeah. So I think some interesting points there. Hanifa, Dina, did you have anything to add on that?
Also, I have a personal experience where lately to transfer the smaller scale into a larger scale, but after we have did a lot of exploration for the material, even observing the ratio of the shrinkage as you mentioned, and also the that might happen. So there is also a very big challenge when scaling up the product or the layer, or even printing on site. So the main problem is when we print off site, we have like more steady the same condition for the prototype from the temperature and the humidity. Unlike if you are in a site, you have a lot of differentiation and the temperature between different the early morning and at noon. We have a different a great change in the humidity and temperature affect back the material behavior itself. So we need to consider this aspect, because each site have its own material environmental conditions that we need to consider while printing. Also, one of the major aspect of the larger scale is the shrink that happen after we build. So during the drying process, we observe a lot of cracking that happen if we are not layers drying at the same time. So this allow us to add more fabrics to ensure that we have a steady humidity for the old material that shrink together and dry together, in order not to have these crackings that have at the end.
And that's a really interesting point about the environment, that you can't necessarily control an outdoor off-site environment, but I guess making materials and processes that are more robust to those changes. Hanifa, you're obviously working on large-scale SLA type devices. I mean, what do you see with what's more difficult about scaling up to those sizes? What issues do we run into that you have to fix?
Oh my God, where to start? Where to start? Well, I wanted actually, when I was thinking about direct 3D printing of buildings, I was just thinking that it can have two benefits, that it will help if we have repair on site as well. Because with the conventional manufacturing of buildings, the repair on site might be very time consuming. It might sometimes not be possible. But I feel like with 3D printing, that's one benefit, that it can actually add value to construction. And also in the harsh environment, I think one of you mentioned that as well, that it's impossible maybe for humans or even for some machinery to function. But if you think about it, a robot loaded with material can do. So I was just thinking that that's the benefit of 3D printing of buildings that I see, and it's a bit different, or is more, when we compare to the mainstream 3D printing. And about the challenges in our technology, like when we are printing larger scale, as all of you said, sometimes when you're printing something in a small size and then when you make it bigger, is a different scenario in terms of shrinkage, in terms of dimensional accuracy, in terms of printer performance, material performance. So all of that, which we need to take in consideration. But again, the beauty of AM, because of this complex geometry freedom that we have, we can design it, we can reinforce it, still keep it light, but reinforce it with different lattice structure, etc., to get to the properties that we want. To be fair, the other challenges I see in building, especially, is the regulation side, that I feel like we can have all of these great ideas, but to convince people to just use these buildings because of the regulation, that I think is the toughest one of the toughest things probably people encounter. So actually, Dina, you had experience, and both of you, Victoria, both of you had experience. What's your experience with regulation and buildings for 3D printing?
Yeah, for what we have done back in Barcelona, it was an experimental model. So we did like a 12 meter square, and this was funded by the university itself. But when we speak or bringing this technology or this knowledge back to Egypt, I think we still have a lot of regulation that not all the industrial sector will accept this technology unless they see something that is printed on in front of them. So I think even this is what Dubai is doing now. They are targeting by 2025 that they have around 25% of the buildings that are 3D printed. And this what they are targeting to start making the building codes in order to popular make popular more popular this technology to be considered as one of the main construction aspect in the sector.
I'm just going to bring us, so we have a couple of questions in the chat that I want to make sure we answer. I'll jump to the third one first, just because it's relevant to what we've just been talking about. Question about whether you've found certain regions or areas in the world where it's easier or more difficult. Do regulations translate across the entire world? Probably not, but is that perhaps, are there regional differences as well, which might make that more or less difficult?
Yeah, for sure. So as Dina was saying, so Dubai is making like a huge effort to try to close this gap if possible. So like to try to really widespread these application for construction by setting like a very high and demanding and challenging target to me. So it's like 25% of the construction is huge for just in just 2 years basically. So, and we all know that like construction sector is very, very slow into like getting these innovations going. So so Dubai could be one, but to me, so I have experience also in the US, and the American standard, it's not the standard itself because it doesn't really get like huge access, or it opens that much to new construction criteria. But the concrete 3D printing industry there is so much growing that I really feel that there's been a push from the industry to get these regulations starting and being more, I mean, getting to work more on these regulations when it comes to concrete, especially because I think there's the need from the industry. So I think that ASTM is now closing the gap from the industry demand to the regulations and the guidelines. So they are working. I mean, I'm also part of a working group on additive construction from ASTM. So I really know that there's this demand and this impelling interest in for industry, but I think it comes from a need. So that's also, I think that for the moment in Europe, for example, there's not such a need or a demand from industry. So that's also why I think there hasn't been this increasing interest, or let's say these working groups from the European point of view, to create a European guidelines, as well as the Americans are doing. So for sure, from the American side, we can then, use them, let's say, or their knowledge in the European region. And I know that, like, for example, for concrete, there's been RILEM that has worked a lot on it, but it's really not an impelling request from industry. So if I can just mention a little bit about metal 3D printing, just because we're interesting things that I would like just to say something of what Hanife was saying regarding our personal experience. So I've been part of the academic members of the MX3D Bridge project. So the first still 3D printed footbridge ever realized, and it was located in Amsterdam, so in Europe. And the guidelines and regulations were, of course, not available. So we had to create design from scratches. I mean, Europe had to set very huge and very high safety factors, so that to be able to for the municipality to accept that design. And for us, like, we had to create like design values and like calibrate safety factors, ad hoc safety factors based on European guidelines for this specific purpose. But I think like this is just one case, and I think like we really need more, and maybe we need some requests from industry in order for the European standard provision to start working really on this.
Wonderful. We've got a few questions through still in the chat. One that's been voted up quite a bit, so I'll go straight to that. Question from someone in the audience says, most 3D printed buildings to date have been demonstrator projects. So, let's show the potential of doing this. What do you all think are the biggest challenges facing non-demonstrator 3D printed buildings? Hanifa, I might come to you first.
Hi. Actually, that was one thing that I was thinking about it, what it actually stops for 3D printing of houses to get to a mainstream. And I was just thinking the regulation is the first, and also education as well. Education in terms of like people to know that this is an option to go to, and it's one option to, just as Dina said, to just make them quickly and affordably. So I feel like that's in not sort of toolbox of so many people yet because of the education. I feel like in US it's better. Usually 3D printing in US is people, they know about it a lot more than us in Europe, and safety and regulation, and also data to support that this building is going to be as durable as the conventional building. And also what is the benefit of, rather than to just make it more affordable and also more faster, what else are the benefit of the 3D printed construction or building? And I feel like if industry again address all of these points, then they have a easier, smoother path to just go forward and just have more 3D printed buildings. Why not? Who doesn't want them?
Honest, I definitely want one. Once we can be certain it's durable and okay, because I guess we are talking very long time scales as well. Often when you're talking about a building, you want something that's going to last forever. Dina, any comments on that? What you see the barriers are of kind of getting to full-on production of these houses?
I guess there is also let me get back comment that I mean, the technology is there, but do we need this technology, or are we our industry need this technology in order? I think also there is a question that mentioned something about the labor market and the impact of the additive manufacturing in the construction. So if we consider that has like more the machinery is much cheaper than the labor. Here in Egypt and the Middle East, we have a lot of labors. The labor market is much cheaper than the machine. So uh, putting the technology here back in Egypt impact the labor market, although it might even raise the awareness and develop the people's skills, but I think it will have a great impact if we didn't consider putting the right um, the right side to what we need for the 3D printing. So because 3D printing, when we see the pros and cons that we can consider, yeah, we have a lot of we can even print in a very fast time. I mean, we can print like a 24-hour house comparing to the something that might take 3 or 5 days. We don't even need any form work. We have much things to save, optimization, more lightweight, but we need to keep into consideration the social aspect that will impact on the society themselves if we integrate this technology to our construction.
Mm-hmm. Yeah, and I'd say it all kind of ties together, doesn't it? Actually, all those different considerations. Victoria, did you have anything to add on that?
I was actually looking at the question on the Q&A regarding labors, and for sure, like the social aspect of this application is huge, and we should take this seriously into account. But on the other hand, so if there is some part of the world in which like there's a big like workforce available, on other parts we are really lacking of them. Like for example, in the US, again, the reason why concrete 3D printing industries are becoming bigger and bigger is also because there's a very scarce workforce available for buildings. So this is also one other aspect that I think it should be important. So for me, is not that it's always like, when it comes to robotization of the industry, you're always afraid that some robot or some machine can take over your work. But that's really not the case, because it's just a change of paradigm and of type of work. So there's no more maybe the need of the specific worker that needs to place a rebar into a reinforced concrete building, which is also a good thing for safety, because that will for sure reduce the the fatalities in the construction sites, which are still like a very important aspect and topic to deal with. But on the other hand, you will have more high skilled labor force, so that will also, I think, increase the need for higher education, and will maybe like widespread more operational schools, or the collaboration between human and robot will become also from the middle school on. So it will become something maybe like really within our society, and not more something to be afraid of.
Yeah, because there's a follow-up comment from Michael in the chat just talking about people pushing for better living standards, but then also an interesting point there actually about unions having good leverage over wages at the moment, but perhaps this could be used to undo some of that leverage. Now, I don't think we're going to fix that problem in the course of a 45-minute panel, but I'm glad it's come up, because I think it's interesting. And the counter to that is, well, if we're talking about upskilling the workforce, is how do we make sure that everyone has those skills and keep up? I did just want to, I've popped a question or a Q&A from something from the Q&A into the chat. So Gregor has posted that the first version of the ISO and ASTM standard additive manufacturing for construction is released. Gregor has said, please read, apply, test, and give feedback. You may regret that comment afterwards, as everyone does. But yeah, so please, everyone, do have a look at that. You know, if you're interested in construction and if you have comments on that. We have another question that's been upvoted a couple of times. So I guess coming back to applications, because we've talked quite a bit about regulations, skills, labour, and so on. One of the things that was talked about quite early on actually was the idea of 3D printing for kind of emergency shelters or whatever, when there's been a natural disaster of some kind, perhaps. Do any of you have any thoughts on that? Have we seen any really good applications of that? Dina, I might come to you first if you have any comments.
Most of the research started to focus on exploring different materials, especially the material that are easy to assemble and disassemble. So I think 3D printing is not taking the rule in the shelter till now, but I guess from now to then they will start to focus on if my environment is enriched with the material that is under my feet, so I can even install the robot and it can very fast the shelters. It will be like a yeah, into sector. But I think now I don't have something in mind that I saw like agree done by the 3D. So
Hannah, Victoria, anything you wanted to add on that side of things, the kind of the more short-term maybe applications?
For shelters or in general for 3D printing?
I mean, we can talk about anything on this panel, Hannah. Specifically, perhaps on the I might roll it into one. I promise I'm not ignoring the question. There's a comment in the Q&A about ignoring the question. I promise I'm not. I'm just trying to lead us in a direction where we'll cover that quite naturally. Perhaps just final comments from any of you on applications in general. So it might be the emergency shelters. We've got a question from Michael about applications of additive construction beyond homes and facades and stuff like that. So basically anything to do with any of that, Hannah.
I just wanted to comment one thing on the shelter. I feel like the reason maybe we don't think about it as an option for shelters, because it's still everything is very expensive in terms of machinery, maintenance, the material of using it. And that's why 3D printing is not extreme, because it's not, we are not making it in large quantities of machines, or it's still a niche technology that they don't know about it. And that's why it's counterproductive when we say, yes, it's affordable because labor is less, but because the machinery is not. We are not making it in vast numbers. It still is expensive. And hopefully by time, and again, education, and also for people to get clever to make the machines more affordable, then we can get to the shelter point as well. But in terms of having them for shelter, there's no problem. It's just we cannot afford it to just build it up in one go. That was my only comment for the shelter.
Wonderful. Victoria, anything to add on any of that?
Yeah, and I think it also relates to the question of applications beyond buildings and facades. So I think, as I said at the beginning, like the real important aspect to me, an opportunity to apply additive construction is to overcome some issues. So, for example, when it comes to some shelters, but also steel structures, for example, grid shells or others. One of the issues is the connection. So, for example, one way to solve and to increase, to speed up the construction process, but also also facilitate it, is to maybe try to come up with some pre-fabricated 3D printed optimized connections and solutions. So for example, one of the projects that one of my students is currently doing, and I'm very proud of, is to realize this and optimize the shelters in which you're using prefabricated tubes to create tents, and so like real quick shelters, and create 3D printed connectors, so that there's also the flexibility and to the adaptation of different dimensions and types of shelters based on the disaster that you have to face. So either you want smaller tents, a series of smaller tents, or one big tent, for example, and those connections can be adapted to these different solutions. So I think when it also is, to me, one of the best way to apply 3D printing could be either for smaller parts that need to that would help to facilitate the construction process. So for example, let's say connections, or to, as you were saying, Anife, at the beginning, it was like repairing, so to strengthen and to repair existing buildings, and so to apply mobile 3D printing, on-site 3D printing, to work on very specific pieces that need to be strengthened, or to apply something on it. So I think this is really important, and also not to mention the possibility to work in a very, maybe a far future, who knows, but to use like these autonomous construction applications for harsh environments. So really help create shelters in harsh environments, and this would also help the work safety and like the safety of the construction sites in general, I would say, not just beyond Earth. I'm thinking also on Earth.
Okay,
Maybe
perfect.
maybe I would like to reflect back to the facade element, especially in our prototype that we built, that's called TOVA. We consider the some environmental performance in designing the facade. So one of the Western facades reflect, or even
inclination angle of the sun. So each opening that we did for the perforation is
responding back to the angle of the sun, so we ensure that the sun is going inside the like a direct
sunlight.
So
I think
this leads to the design process
to optimize the geometry or even the opening that consider the environmental aspect, either the air ventilation or the sun or
other
factors, to consider that
the 3D printing will only
we are designing. So
this
is one of the
possible
things that
3D printing can assess and very needs.
Wonderful. So I'm going to move along just for the last bit of the session, because actually, and the question from the audience is very relevant there. So if I want to go out and buy a laser sintering machine, I can go out and buy a laser sintering machine of lots of different sizes and volumes and whatever I need. Where are we in terms of actual bespoke equipment? And I will mention, so the question from the audience is, does anyone have any knowledge of the 3D printing robot by the company Apis Core? Are there similar technologies out there? What's the scene like in terms of actual machinery or equipment that we could go out and buy? Victoria, I might just ask actually if any of you want to jump in on that, if you have experience of any of that equipment.
Yeah, I can say something. So I know of Apis Core, just of course for the projects that they have been working on. I honestly I have to maybe ask the person who wrote the question to maybe be a little bit more specific on why exactly do we want to focus on that specific industry for any specific reason. I mean, I personally see that Apis Core is one of the many. For sure, it's like it has been one of the first. But I personally see that, of course, like they have printed like entire buildings in Dubai, as well as Icon has printed an entire village in Texas a couple of months ago. So I personally see that like this is IPE score, if I remember correctly, is like a gantry system, but it's something that it's been used for concrete buildings and concrete unreinforced masonry units. That's how they call it. And personally, I might not be the biggest fan of that, just because it's limiting the the geometry building to be printed within the gantry itself, because it's like contained. So this will maybe raise to me a few questions on what would be then like the improvement with respect to what's done already. Like, what would be the one of the pros of using that for additive construction? Don't get me wrong, I would love to have a house built by Episcore, but it's more of the relevancy on a longer term. So to me, it would be, as I said, make an efficient use of these applications. So it's also like based on the cost relation, and but it's not just API score. I also want to make it clear that I'm not really sure why we should focus specifically on that, but it's more of a general.
Dina, Hanfa, anything to add on that? If not, I can move us on to the other question that we have in the chat. So thank you to the audience. I had a list of questions which we'd already discussed, most of which have gone by the wayside because you've all had lots of questions, which is wonderful. It's really nice to see that level of engagement from the audience. We have a last question in the chat from Michael, which comes back to your point, Dina, about environmental factors when you're doing on-site 3D printing. What are the pros and cons of that? Can we do stuff off-site and bring it to site, or is it better to be doing it on site? Or I hate when someone drops. Go for it, Hannafah.
Maybe I can answer from the polymer point of view. So because this question, we get that any material that we want to use outside for that tell us like this material, how long it's going to last. Is going to last 5 years? What's going to happen in 5 years or 10 years time? So there are already some standard that we use that for long term testing, which yes, they are kind of like fast testing of those materials in terms of aging. It's a environmental chamber at a constant temperature, constant humidity, or constant UV, etc., etc. Which I think the same can happen for construction, and I'm sure it's happening for construction when they are introducing new materials. So based on those standards and what's already happening, we can actually have an idea what will happen to that material in a real life, or that building in real life, with some fast testing, and which I'm sure Dina can comment better on that one.
Yeah, concerning the environmental factor first, as we mentioned in the first, that we are facing a lot of differentiation in the temperature and the humidity if we are on site. So if you are in a country that have a specific aspect, other environmental or the location you are in. So we need to see the behavior of the material, how it will behave, and for example, in a temperature that that's so too cool, so the water inside the material will be more
Frozen.
Yeah, frozen, and it's hard to extrusion. So we need to control the speed and the pressure. Unlike if it's more wet, we need to consider the speed and increase the extrusion. So we need always to put an eye on the material behavior and the environmental aspect that we are facing. And also the material, if we are printing with concrete, it's dry. Need like 4 days to dry. So those aspects are impacting the project, even the length of how the project is gonna dry fast. So if we can reach like one-story building with concrete in less than 1 day. However, with clay, which is more friendly, we will need like 3 days to ensure that the building is like ready and dry after the impact.
Perfect. So I'm aware of the time. We have networking after this, so we don't have to finish this exact second. But I thought I'd like to. There's always things that you talk about in a panel that you think, oh, I really wanted to talk about this. So I wanted to finish off just with, for each of you, is there anything you wanted to say or talk about in this panel that we didn't touch, but that you think would be really interesting to the audience to hear? Hanifa, I'll come to you first on that.
I genuinely had a question actually from Dina and Victoria because they're more experienced in actually building by 3D printing. Is there any, I'm sure it is, but do you get to any dimension limitation, like I can only make a 3 stories building or just one, or and how the technology is going to get around these limitations?
Yeah, for the clay, I think the clay has some limitation and the compression strength. So we need to consider like 1 story or maximum 2 story building. Otherwise, adding more
concrete and so on. For concrete,
I think it
we
might reach like
3 or 4 building, story building.
and even in China, I guess they reach 7 floors with considering that they 3D print the facade itself and even assemble them to this. Some limitation here, I guess, for example, if we need like the control, the cantilever, the maximum cantilever, and even the angle of the opening, it can be a limitation considering the material we are doing or building with.
And then I guess, yeah, Victoria or Dina, any last things you wanted to definitely say today that you were really excited to tell everyone about?
Well, I think that like 2 things that I'm very passionate about is for sure to like reduce the environmental impact of construction, which is currently like 50% of the overall CO2 emission in the world. And I think like there's like this huge opportunity out there, and it's like with additive construction. And I think if we all make this effort towards reducing that impact, but also facilitate the use of additive construction in a more efficient way, like to create efficient constructions that would, be such a positive impact for our world and our society, that I think we should all just, think about that and focus on that even more.
For sure, that's a wonderful point to make.
Yeah.
And Dina, any last things from you?
Yeah, maybe I will also emphasize on the environmental impact from a different perspective, that we need to consider the material. We need to consider the eco-friendly materials such as earth, clay, salt, and whatever we have under our feet in order not to start importing material
which even consume a lot of
energy and carbon emission.
concrete. I know that
The concrete is super fast in 3D printing, but there is a lot of emissions that they consume. So we need to
limit the use of the industrial material
that for our environment.
Well, I think that's a wonderful point to finish on. Thank you so much, all of you. It's been a genuine pleasure to get to share the stage a tiny bit with you, but hear all of your thoughts from all of your different expertise and experience. It's a lovely thing to be able to do on a work afternoon. So thank you to all of you. Thank you to our other speakers this session. The next thing that's happening is networking in the main stage, and then there'll be the next keynote, which I think is the Girl Gang Garage one. I'm just checking back on our screen. Yeah, so there's about 30 to 35 minutes of networking. As I say, if you want to go over to the main stage now, you'll be able to do that. And thank you to all of our speakers for this afternoon. You'll get, I don't know if you can see, there's claps rising in the chat. say thank you to everyone.
Thank you, and thank you, Candice, for helping us with the panel.
Thank you.
Yes.
Have a lovely afternoon, everyone.
Thank you
You
for
too.
having us. Thank you. Bye-bye. Bye.
Thank you. Bye.